Mean reversion is the idea that a variable tends to return toward its long-run average value over time. In finance and economics, many variables such as interest rates, stock correlations, returns, and volatility often move away from their normal level temporarily, but later move back toward that average. When values are very high, there is usually downward pressure. When values are very low, there is usually upward pressure. This natural tendency to move back toward the average is called mean reversion. To understand mean reversion, we first look at how a variable changes between two time periods. We compare the current value with the previous value and measure the difference. This change tells us whether the variable increased or decreased from one period to the next. The important idea is that this change depends on how far the previous value is from the long-run mean. Mean reversion implies a negative relationship between the change in the variable and the value in the previous period. This means if the previous value was high relative to the mean, the next change tends to be negative. If the previous value was low relative to the mean, the next change tends to be positive. In simple words, the variable is pulled back toward its average level. The strength of this pull is called the mean reversion rate. This rate shows how quickly a variable moves back toward its long-run average. A small mean reversion rate means slow adjustment. A large mean reversion rate means fast adjustment. For example, if the long-run average is 80 and the current value is 50, with a low mean reversion rate, only a small portion of the gap is corrected next period. Asterisk with a higher rate, a larger portion of the gap is corrected, so the value moves back faster. A stronger mean reversion rate means stronger attraction toward the mean. The full mean reversion equation includes two parts. 1. The predictable movement toward the mean, and 2. A random or stochastic component that represents unexpected shocks. The random part reflects real-world uncertainty and noise in financial data. To make learning easier, we often simplify the equation by ignoring the random term and assuming a fixed time step. After simplification, the expected change becomes proportional to the distance between the current value and the long-run mean, multiplied by the mean reversion rate. This simplified version helps us understand the core concept clearly. Mean reversion can also be estimated using standard regression analysis. We rewrite the mean reversion equation in regression form, where the dependent variable is the change in the variable, and the independent variable is the previous period's value. The regression equation takes the form y equals alpha plus beta times x. When we compare this with the mean reversion equation, we find the regression beta coefficient equals the negative of the mean reversion rate. So, negative beta indicates mean reversion, and the size of beta tells us how strong the reversion is. Interpreting regression results. Suppose the regression result is y equals 0.3 minus 0.70 times x. The beta coefficient is negative 0.70. This implies a mean reversion rate of 70%, meaning about 70% of the deviation from the mean is expected to be corrected each period. A high absolute value of beta indicates strong mean reversion. This means large increases are likely to be followed by decreases, and large decreases are likely to be followed by increases. Understanding mean reversion helps analysts estimate expected future values and explains how financial variables behave over time.